Today we're going to talk about circuits. We're going to start a new unit. We're going to do a lab today, but in order to get you ready for the lab, we have to talk about a few things. So let's talk about this word circuits first. A circuit is just a closed loop through which charges can continuously flow. And you can see how the word circle is kind of in the word circuit, so you kind of want to keep that in mind, okay? So there's a couple of things we need in order for us to have a circuit. And the first thing we need is we need an energy supply. So that's the battery. Right? The battery is going to be the energy supply, and it's going to push the charge through the circuit. It creates an electric potential difference across the circuit. So we're going to study electric potential difference in detail later on in the unit, but for right now, for the circuits, you just need to know that you need a battery. The second thing you need is you need a closed conducting loop on the external circuit. The battery is basically the internal circuit. We're not going to worry too much about that right now. But the external circuit, we need this loop, okay? Just like we need a circle here. So the wires and the light bulb and the switch and the battery that we see, they're all part of the circle that the charge can go from one part of the circuit to the next, and it's a complete circle, okay? And then we need some components as well. So we can see three components in this circuit right here. We can see the battery, which provides the electric potential difference. We can see a switch right here, and we can see the light bulb right there. Now, when we take a look at this, we see that we have different color wires here. And the reason we have those different color wires is because they're labeling an area of high electric potential and an area of low electric potential. So right here, this wire right here, including this switch, all the way to that side of the light bulb, that's an area of high electrical potential. This next wire over here in this pink, this is an area of low electrical potential. And we're going to kind of keep an eye on that as we go, okay? Now, what we've shown in this first drawing is a pretty straightforward, you know that that's a light bulb, you know that that's a battery, and you probably know that that's a switch. They're a little harder to draw, so we went ahead and drew a second drawing, which is closer to what you're going to have to do today. So your battery is going to look like this, and the longer line represents the positive side, and the shorter line represents the negative side. So this right here is the longer line, this right here is the shorter, and there's various cells in the battery, so we went ahead and put a couple in there, okay? A switch looks like this, and we usually draw it in the open position. For instance, right now I can tell that it's open because current can't flow from the battery all the way over to the light bulb because it gets stuck right here, okay? So since the current can't get through, this is an open switch right now. We normally draw that as open just because it's a little easier to see, all right? And this right here then would be our light bulb, okay? What you're gonna notice is that every component has two terminals. So there's a terminal for charge to flow into, and there's a terminal for charge to flow out of. So for instance, the two terminals for a battery, one would be on the positive side, one would be on the negative side. The two terminals for the switch, one's here and one's there. And then there must be two terminals for the battery for the light bulb as well. So we're going to get into the light bulb because we want to make sure you understand how those work. So it's going to be your job to figure out where the two terminals of the light bulb are, but it's it should be pretty clear after we talk and after you try a little bit in the lab. So let's talk about the parts of a light bulb for right now. The most obvious part that you're used to seeing is the gas-filled glass. Right? Now, the part that actually lights is this right here. This is called the filament. It's a really small wire that glows when we have a current that goes through it. Okay? Now, if we have current that goes through it, that means that filament must be electrically connected via a conductor, because for a circuit, everything that's in the path of the circuit needs to be a conductor. So that must be electrically connected via a conductor to the rest of the circuit. So here, right here, is one lead. And here is another lead. And it's not super obvious where those leads go to. And it's hard to tell by looking at the light bulb where they go. But I can tell you some hints here. So some other parts of the light bulb. This is the base right here. This is a metal base, okay, that you can go ahead and screw into a socket. And then underneath there, and you can kind of see it in the picture, there's this little black part right there. That's an insulator. Okay, so that separates the metal base. And then right down all the way at the bottom, you're going to see another kind of a metal knob. Okay, so those are the main parts of the light bulb that you're going to get familiar with today. You're going to go ahead and light a bare light bulb, and then you're going to put a light bulb into a socket, and you're going to light it with a battery in that format as well. Okay, and as part of that, we're going to have you do some drawings and take a look at some drawings. So let's take a look and see how we're going to draw our battery. And there's different ways you can draw a battery. So we already saw up top how we can draw it as cells. And really the number of cells isn't really important. But we know that this is the positive cell and this is the negative cell. So normally when we draw it, we put the positive cell on the higher part of the page. Okay. You might see a battery drawn a little differently because you could just draw it like it looks like a battery, kind of like this. And you put the little knob there, and then you would know that this is the positive end of the battery and this is the negative end of the battery. Some people show it like this, where you just draw a circle. I won't do that. It kind of means something else, where this is the positive and negative part of the battery. So you might see a couple different things as you read and get more familiar with electric circuits. The switch we saw above, mostly we draw it like this. We have a wire coming in. We show that there's one end of the switch. So this is the kind of the lever that moves. And then we show the other end of the switch connected to a wire. So this is an open switch. To draw a closed switch, it's pretty simple. You're just closing that down there. So this would be a closed switch. But like I said, we're normally going to draw that in the open position. A light bulb is pretty easy to draw unless you're trying to draw an accurate depiction of a light bulb. But in a circuit, it's pretty simple. We pretty much draw a circle with another circle in there, and then you connect it to some wires. That's a light bulb. And we're going to talk about resistors. A resistor that you're going to see in a circuit is just kind of a M or a bunch of W's put together. And that's a resistor. This resistor can represent any electrical component that converts electrical energy or electric potential energy into something else, into light or heat or sound or movement. Okay, so a resistor is kind of a generic component in a circuit. We could draw the light bulb as a resistor as well, and we'll get to do that eventually. But for right now, we'll just go ahead and stick with drawing the light bulb as the two circles. In the lab today, we're going to focus on two types of circuits, and these are the two main types. The first is called a series circuit. So a series circuit is a circuit that's just one complete circle. And it looks like this. We've got a battery, and it's connected via wires. And if something is connected in series, we're going to have two light bulbs in series for this lab. You can have as many components as you want in series. You could have 3, 4, 5, whatever. But you usually have two or more connected in series. To have one connected in series, that doesn't make a whole lot of sense. So we're going to show how we would connect two light bulbs in series. So here's one light bulb. And here's the other light bulb. And that would be my series circuit. So these right here, these are just wires that would connect, and there would be different wires that we would connect, okay, each of the components to the battery. But you can see that you can make one complete path. So if I start at the top of the positive end of the battery, I could go through this wire, through the light bulb, through the next wire, through the light bulb, and through that next wire, all the way back to the battery, and never have to pick up my pen. That is one complete circuit, okay? So what is flowing here, and we're going to talk about current. We've got current flowing through, and current is just a flow of charge. So the battery, once we connect the battery to the light bulbs, we are going to see that current is going to flow, and you're going to measure that. And it's going to flow from the positive side of the battery. We'll talk more about that as we get there, why it flows from the positive side. And then it's going through that wire to the first light bulb, through the next wire to the next light bulb, and eventually get all the way back to the battery. The current's going to go into the battery, and then the battery's going to do its job of basically increasing the energy level of each of the electrons that enters it, okay? So that's a series circuit, and you're going to get some practice today wiring that up and then doing some measurements with that we'll talk about in a second, okay? The next type of circuit is a little different. It's called a parallel circuit. So for a parallel circuit, we could have 2 or more complete circles. So that looks like, again, we still have to have our battery. We always need some kind of energy source. And we're going to have a wire, and it's going to go to one of our light bulbs. And then that wire will go, another wire will go back to the battery. And then we're going to have another battery, another light bulb. And now hopefully you see why those are connected in parallel. So what we've got here is from the battery, I can go one complete path, but I only get through one of the light bulbs. I have to take a second path to get through the second light bulb. So I've got one complete circuit here with one light bulb, and then I've got another complete circuit here, complete circle with the second light bulb. And you're going to get a chance to see how that's going to work and how the light bulbs are going to be different when they're connected in parallel versus in series. So when we take a look at current flow, we're going to see here that we've got current coming from the battery, okay? And then it's going to go, some of the current will go through one light bulb, okay? And some of the current will go through another light bulb. And then we're going to have both of those currents returning back into the battery. So you're going to get a chance to measure those. Speaking of measurement, let's talk about how you're going to do the measurements in class today. So you're going to see when you go back to the lab that you have 2 devices. One is going to measure electric potential difference, and it will say voltage on somewhere on the device. We're going to talk about voltage, but for right now we're calling it electric potential difference. And you're going to see one that says current. Okay, so let's talk about voltage first. In order for us to measure voltage, we have to have a complete circuit. So you see we're missing a line there, so we're going to have to throw another wire in there. And then you're going to see you're given the electric potential difference meter, and it's going to have a V on there, and it's going to have 2 leads. It's going to have a red lead, and it's going to have a black lead, like that. And you're going to see that for the light bulb, there are 2 either nails or screws that are the terminals for the light bulb, okay? So you're going to take the red lead and you're going to connect it to one of those terminals, and then you're going to take the black lead and you're going to connect it to the other terminal. And then you're going to hook up your electric potential difference meter, and through your iPad, I'm not sure if we're going to need a stream or if we're going to be able to just connect it directly to our graphical analysis. And you're going to be able to read the voltage across, and we say it's across, so we're going to read the electric potential difference. And this is the key here, the electric potential difference across the light bulb. Now think about why we have to measure it across. If we're talking about a difference, what we're really measuring is the difference between the electric potential here on one side of the light bulb versus here. And we're going to go ahead and define these terms to you later, but for right now we just want to get the measurements. Okay, so we're measuring the electric potential difference across the light bulb. So a difference, basically an energy level from one side of the light bulb to the other. Okay? So getting the voltage, the electric potential difference is pretty straightforward. That's all you're going to probably have time for today. But let's go ahead and talk about the current. And you can come back to this video and watch and see how we connect up the current, because it's going to be slightly different. So with a current, we're going to measure the current through, and that's a big difference, through the light bulb. So we have to connect it differently. Okay, and by the way, if you're measuring the electric potential difference, the light bulb has to be on. If it's not on, you're not measuring the correct value. Okay, so make sure that that's on. Now, for measuring the current, we're measuring the current through the light bulb. So we have to connect this differently. So what you're going to see is that you're going to get the current meter, and it's going to have an A on there. And again, there's going to be a red wire, and there's going to be a black wire, and you're going to connect those. but you're going to have to disconnect. If you had originally put a wire here, you're going to have to disconnect that wire. You're going to have to remove it. Because what we really want to do is connect the current meter to one side, let me change the color there, from the red wire to one side of the light bulb, okay, right next to the light bulb. So one of the nails or screws right next to the light bulb. And then the other side of the ammeter will go to where the wire came from. So think of it this way. We removed this wire. So this was our complete circuit right here. We don't have to worry about the voltage, the voltmeter or the electric potential difference meter. So this is our complete circle. We removed this wire. We want to replace this wire with our current meter. So basically what we want to do is we want to replace a wire with our current meter. So for a minute, for however long it's disconnected, the light bulb will be off. Okay, that's just going to happen. Then once you hook up your current meter, the light bulb should go back on. This has to be on to measure the current. So if you hook up your current meter and you don't, the light bulb doesn't go on, something's gone wrong. So check it and see if you can figure that out. Now, if you remove, which wire you remove, it depends on which bulb you're measuring. You want to remove a wire that's as close to the bulb as possible. So this wire worked. This wire would have worked as well, okay? And then you're going to have to get the current going through the other bulb and the current going through the battery. So you're just going to change out which wires you're removing. Once you take this current meter out, go ahead and replace the wire so that the light bulb comes back on, and then you can replace a different, remove a different wire, and then move your current meter as needed. Okay? That's the essence of the lab we're going to do over the next couple of days. So good luck, and if you have questions, make sure you talk to your teacher. Bye-bye.